Hello everyone, I hope you're doing well. So in this video, we're going to discuss the first three problems of Codeforces Round 868, which was written for Division 2. So this contest was actually held yesterday, but due to some reasons, I was not able to give the contest. That is why I opened the problem set today, and by judging the number of submissions, I decided to solve the first three problems and make an editorial for it for now. Right. So let us quickly start with the first problem, that is a characteristic. So this problem says that we have been given a size n and we have to consider an array such that it only consists of 1 and minus 1 and the size of the array should be exactly equals to n, right? And we have been given a value that is equals to k, right? So we have to tell whether with the given values n and k, can there exist an array such that there are exactly k number of pairs I and j such that a of I and a multiplied by a of j is equals to 1, right? If it is possible, then we have to print yes, and we also have to print the input array, otherwise we have to print no, right? So let me just quickly explain what this problem says. So these are the sample test cases that we have, right? So if in the first test case the value of n is 2 and the value of k is 0, right? So that means there should be 0 pairs I comma j such that ai multiplied by aj is equals to 1, right? So they have given that yes, it is possible and the array can be 1 and minus 1. So you see, if you multiply both of these, it would be minus 1, right? And there can be no other pairs of I and j. So let us take some other example now. So the next example that we can take is 3 comma 3. So this is the 1 2 3 4 fifth test case, and we have the answer as 1 2 3 4 5. So for the fifth test case, the answer is yes, and the array is 1 1 1. So if you take this particular array, then you can make like 3 pairs such that I is this and j1 is this and j2 is this, right? Again, I can be this and j can be this one, right? So there will be a total of 3 pairs, right? That is I j1 j2, and let's say this is I2 and j3. So it will be I2 and j3. So these will be the 3 pairs. Now, how do we actually form this answer? Now we have understood the question. We will discuss how we can form this particular answer. You would observe that ai into aj will be equals to 1 only when ai and aj are both 1 or ai and aj are both minus 1, right? So this is our first important thing about the problem. Since these are the only two values we can take, these will be the only combinations that we can form. Now, if we have multiple number of ones, right? If you have some number of ones, how many pairs can I form with these number of ones? So the first one, let's say these are n number of ones. So the first one can combine with the remaining n minus 1 ones, right? If we have now for the second one can combine with the remaining n minus 2 ones, and so on. So for n number of ones, the answer will be n minus 1 plus n minus 2 plus n minus 3 plus n minus 4 and so on up to 1. So if there are n ones, we can essentially form n into n minus 1 by 2 number of pairs, right? Similarly, if there are n minus 1s, if the frequency of minus 1 is n, then we can form again n into n minus 1 by 2 pairs, right? Now if you look at the constraints of this particular problem, the value of n is 100, and since each character can be either 1 or minus 1, so we can iterate through all the values, whether they first we'll assume that there are 0 ones and n number of minus ones. Let's say these are ones and these are minus ones, and then we assume that there is 1 1 and there is n minus 1 minus ones, and we assume there are 2 ones and n minus 2 minus ones, and so on up to this will be n and this will be 0. So we can calculate the frequency of all the characters, like starting from 0 till n, and the corresponding will be n minus I. So if the first value is I, the second value will be n minus I, and for both of the values I and n minus I, we can calculate with this particular formula. This will be I into I minus 1 by 2, and this will be n minus I into n minus I minus 1 by 2, right? So these two values will be the number of pairs we can form. If we add these two values and these are equals to, this is equals to k, then we can say yes, and the answer is possible, and we can just print I number of ones and n minus I number of minus ones. Or it can also be the opposite, it doesn't matter, right? So let me just show you the code for this particular problem now. So this problem was very simple, and you can see what I've done is I've taken two variables n and k, and I've taken input, and for I just traverse through 0 to less than equals to n. Now neg will be the number of negative values and pos will be the number of positive values, right? So if number of negative values or -1 is I, the number of ones will be n minus I. So I calculate how many pairs are possible with these negative values. I calculate how many pairs are possible with these positive values. Now I do x plus y is equals to k. If the sum of these values is equals to k, then I print yes, and I print all the negative values and I print all the positive values, right? At the end, I can just return. If I have found my answer, I can just directly return from here only. Otherwise, I can print no, right? So this would be the solution for the first problem. Now starting with the second problem, it says that they have defined a permutation. So a permutation is any array of size n which consists of every number from 1 to n exactly once, right? So we have been essentially given a permutation of size n. Now we can make certain operations on this particular array, and that are, if we have been given a value k, if the difference in positions of two elements is equals to exactly k, right, then we can swap them, right? So they say like some arrays with this particular method cannot be sorted, so they have allowed us one exchange, right? So we can choose any two values and swap them, right? So we have to tell whether we can form our answer without performing this preliminary exchange, right? Or we can perform our sorting operation with this preliminary exchange, and remember we can like only do one such exchange, and if we cannot sort the whole array even after performing this particular exchange, then we have to print -1, right? So essentially the question is what we can do is we can swap all the elements that are at a difference of positions equals to k, so it should be exactly k, right? So they have allowed us at most one preliminary exchange, so in which we can choose any two positions, right? So in this case, k is not a concern, we can choose any two positions, and we have to tell whether we can sort the whole array or not. So if we can sort without this preliminary exchange, we have to print 0. If we can sort with this preliminary exchange, we have to print 1. If we cannot sort even after this particular exchange, we have to print -1, right? So this is the whole idea of the problem. Now how do we actually solve this problem? Let us have a look at this now. So I am just copying this particular sample test cases. So these are the sample test cases that we have, right? Since this is a permutation, if we try to see the final array or the sorted array, it would only look like this. So it will be like this up to n, right? This would be the final sorted array. Now it says that we have a value k, right? We can only swap elements that are at a difference of positions k. So if we have like 10 elements, let us take a smaller example first. If you have let's say 6 elements, so one is like this, 2, 3, 4, 5, 6. So for the first position, the next element would be this, right? For the second position, the next element would be this. We'll be just mark them together. And for the third position, the next element would be this, right? Now even if we try to extend this further, let us extend this 7, 8, 9. So after this 4, 7 will come. After this 5, 8 will come. And after this 6, 9 will come. So you see it forms something like a graph, and since we can swap these elements, all of the elements that are connected, we can swap these elements no matter what is the arrangement of these elements in this particular connected component, the answer will always be the same. So let me just explain you in simpler terms. So if 1 was here, 8 was here, let's say 3 was at its place, 4, and then let's say 5 was here, and then 6, 7 and 2 and 9, right? So 8, 5 and 2 were connected, right? Let me just erase the circle from 1. So we have 8, 5 and 2 connected, right? Because like the difference between these two is 3 and the difference between these two is 3. So in this case we are assuming k to be 3. Now these all three elements are connected. Now we can take any element and put it to any element's place. It is always possible to arrange these elements in sorted order. Why? Because I can take this 2 and swap it with 5, and I can take this 2 from here. So let's say after swapping one operation, it was like this, 8, 2 and 5, and then I can take 2 here and then 8 and 5, and then I can final operation I can do like this. So since there are no constraints on the number of operation, I can always make any permutation of these particular characters, right? So as long as the correct the three elements that we have here are the elements that were essentially in the correct order. So if in the correct order 2, 5 and 8 were here, then in this particular order also 2, 5 and 8 should be present. The order in which they are present doesn't matter. It's just that all these three elements 2, 5 and 8 should be present. Similarly goes for other components as well. So if 1, 4 and I guess 7 was together, right? So if these three elements at these positions, at the 1th position and the 4th and the 7th position, as long as these elements are equals to 1, 4 and 7, no matter in what order they are present, we can always swap them and sort them in the correct order, right? It's just that the element should be the same. Now what happens when some element is not same? Now that means, for example, if let's just take the smaller example now. So if 1, 2, 3 and 4 is present, so 1 and the value of k, let's say it is 2, right? So 1 and 3 we have here and 2 and 4 we have here, right? So even if the order changes 3 and 1, 2 and 4, it doesn't matter, we can always swap them. It's just that at this position and its position, when we take them together, 1 and 3 should be the only elements present. But what happens if these are not the elements that are here? So let us say that it is 1 here and 2 here. Now you will see that if we take these two positions, then 1 and 3 should have been present, but now instead 2 and 3 are present, right? So 2 is the only different element. Now if we consider some array like this, 1, 2, 3, 4, 5, 6. Now this is an array of size 6. Now let us if the value of k is 2, then 1, 3 and 5 should be together. But let's say the permutation is like this, right? So now the elements that should be together are these ones. So 1, 2 and 4 are together. Instead 1, 3 and 5 should have been together, right? Now no matter what you do, since there are two elements that are different, the original array that we needed was 1, 3 and 5, but since two elements are different, 2 and 4, what we will, no matter what we do, we will never be able to form our answer. So for example, if we try to swap 2 with some element to bring 3 back here, right? So for example, 3 was there in some other group. So if we try to bring 3 back here and replace it with 2 in that particular group, what will happen is 3 is changed, but now 4 cannot be changed, right? Similarly, if we try to bring back 4, we will not be able to change 2. So if two elements are different, that is the position from where we can directly return our answer no, because in this particular case the answer will never be possible, right? Since we can only apply one operation. But let's say we needed 1, 3 and 5 and we currently had 1, 3 and 4, right? Now if we can replace this 4 with some element such that we can bring 5 back here, and that particular component needed 4, right? So if by doing this particular operation we can put 4 back in its correct position and bring 5 back here, that means we can form our answer, otherwise we cannot form our answer, right? So in this case we will be able to form our answer by using one operation, right? So first of all, we discussed that if we talk about a single component, then if two values are different, then the answer is straight away no, right? If one value is different, let's say this component has one value different, this component has one value different, this component has one value different, and this component has one value different. So let's say this component has the value from this particular component and this particular component has the value from this particular component. So essentially one value from here and here is exchanged. So we can make one operation to swap both of them. But even after swapping, what will happen is these two components still have some incorrect value. So even after one operation, we cannot form our answer. So there has to be exactly two such components such that exactly one value in them is swapped, right? So we can take this value here and bring back the original value from here, right? So this is the only way in which our answer would be 1. Otherwise the answer would be -1, and if there are no such components, all the elements are present in the correct components, then the answer would be 0, right? So let me just show you the code for this particular problem now. What I have essentially done is the code. So you see, I have taken two variables n and k, and I have created a vector of size n and taken input. Now I have initialized a variable count. So I just traverse through 0 to less than k. So what I am essentially trying to do is I am trying to divide the whole segment into k groups. So for the first group, I can start from I and I can just increment j by k, right? So I am inserting all the characters that should be present in that particular group into the set remaining, right? So I just insert all that elements into that particular set, right? So once I have all the elements that should be present in my current order or in the current component or in the current group, I just add it to my remaining elements. Now I check which of the following elements are actually present in their group. So there are some elements that should be present, and there are some elements which are actually present. So I just remove all the elements, I just erase them from the set which are actually present in my array. So if the size of remaining elements is greater than 1, that means there are greater than 1 elements which do not belong to this particular group, then the answer would be straight away -1, right? Now if there is exactly 1 element, then I'll increment my count variable by 2, right? So at the end, after all of this is done, if the value of count is equal to 0, that means I have all the elements are in the correct groups, then I just print 0. Otherwise, if exactly 2 of the elements are in their incorrect groups, then I can just swap them using one operation and find the correct answer. Otherwise, I'll just have to print -1 because I cannot form my answer at all, right? So this would be the solution for the second problem. Now let us have a look at the third problem. So this third problem was simple yet interesting at the very same time. So I will tell you, like, this I found this problem interesting, but yet this problem was not very difficult. So let's say they have defined what is a prime number. So we'll not discuss this, we'll just discuss at this particular second definition of strongly composite numbers. So we already know what is a composite number, right? Now if the number of prime divisors of any particular number v is less than or equals to the number of composite divisors of that particular number v, then v is called strongly composite, right? This is the definition of a strongly composite number that they have defined. So if the number of prime divisors of a number is less than or equals to the number of its composite divisors, then it is called strongly composite, right? Now we have been given an array of size n, and we have to build an array of size k, right? So we don't actually have to build this array b, we'll have to output some value. So let's say that the size of array b is k. Now we have to build the array b such that the product of all the elements in a is equal to product of all the elements in b. All the elements of b are strongly composite, and the size k of the array b is maximum possible, right? So in this particular case, we have to print the size k of the array b, which will be the maximum size of b satisfying all the conditions, right? So this is essentially what we have to do in this particular question. Now we'll not discuss the sample test cases. I'll just explain you some theory, some cool mathematics theory about this particular problem. So we'll explore, if we have a prime number, let's say 3, what are all the operations we can do with this prime number, right? So you can multiply a prime number with a composite number or another prime number. So since the first value we have taken is a prime number, it can never be strongly composite, right? So we know that the prime number can never be strongly composite, right? Now what we can do is we can take a prime number and multiply either with a composite number or with a prime number. So in both of these cases we will get some value. Now if you multiply a prime number with a composite number, you would always get a strongly composite number, right? This is a very important you would say fact that you will realize. I'll prove it how. But whenever you multiply a prime number with a composite number, you will always get a strongly composite number. Why? Let me explain. So if you have a prime number, let's say 3, and you have a composite number, let's say 6. Now if you multiply both of them, the number of factors or the prime factors might increase or still remain the same, but the number of composite factors will always increase. Let me show you how. So if we have 18, so 6 has essentially factors 2 and 3, right? Now we have 18, that is 3 into 6 is 18. So now we have the factors 1, 2, 3, 6, 9 and 18, right? So 3 was taken essentially from here, 2 was taken from this particular place, and since 3 was common in both of them, these are the two factors that we have, right? These will be the prime factors. Now since 6 is also a factor that is taken from here, now we can do combinations among these, right? So 6 into 3 would be 18, right? So 1 3 was here, 1 3 was here. If you multiply both of them, we will get a composite number 9, right? So you will see the composite number will always become greater than the number of prime numbers, right? So if you multiply any prime number with a composite number, it will always be a strongly composite number, right? So this is our very first observation. Now how did I reach this place? I was trying to find some composite number such that it is not a strongly composite number. right? So the first number that I found was 6. So 6 was a composite number which is not strongly composite because the factors of 6 are 2, 3 and 6. So these two are prime divisors and this is a non-prime divisor, right? Now since it is greater than this particular value, 2 is greater than 1, that means it is not a strongly composite number. So if I multiply this particular non-composite number with another prime number or any other number for that matter, it will always be strongly composite. So from there I reached this particular conclusion that if I have a prime number initially, I multiply it with a composite number, no matter if it is strongly composite or not, or a simple composite number, it will always be strongly composite, right? So this is my first definition. Now if I have a prime number, right, if I have a prime number and if I multiply it with another prime number, right, now two things can happen. The first thing is the both of the prime numbers are essentially the same number. So if I multiply 3 by 3, 3 by itself, so you will observe the number of factors of this particular number will be 1, 3 and 9. So in this case, the number of prime divisors and the number of composite divisors will become equal, right? Even if you write 2 into 2, the number of prime divisors 1, 2 and 4, number of prime divisors and number of composite divisors will be equal. So this will be a strongly composite number, right? So if we multiply the same prime twice, it will be a strongly composite number. Now if we multiply a prime 1 and multiply it with another prime 2, this number will always be a composite number but not a strongly composite number. Why? Because if we multiply 2 by 3, it will be a composite number, correct? But there will be two prime divisors and let's say this is 6. This is the same example of 6 that we had considered earlier. So it is 1, 2, 3 and 6. So there are two prime divisors and one non-prime divisor. So it is not a strongly composite number. But again, if you multiply it by our prime divisor, then we get to the first definition. Now since we have three prime numbers P1, P2 and P3, if you multiply for the first two of them, it will become a composite number C1, and if I multiply this composite number with this prime number, it will become a strongly composite number, right? So that means if I have two prime numbers that are same, that means I'll take both of them and make a strongly composite number. If I have three different prime numbers, I can take three of them and I can make a strongly composite number, right? So I can solve this problem greedily now. I can I can make the whole number n and find the prime factors of it. So let's say P1, P2, P3, P4, P5, P6 are same. If I multiply all of them, I'll get n, right? So since I want to increase the number of elements in my array B, what I'll do is I would want to take as few of them as possible, right? If I can take two of them and make a strongly composite number, I'll take it. If I again take two of them and make a strongly composite number, I'll take it, right? So that way, what I'll do is I'll do the prime factorization of n. I'll find that for the, let's say that it is the prime factorization of n is 2 into 2 into 2 into 3 into 3 into 3 into 3 into 4, 3 into 5. So I cannot take 4 since like 4 is a non-prime number. I am only counting the prime divisors. I can take these two together to make a strongly composite number. I can take these three together to make a strongly composite number. I can take these three together to make a strongly composite number. So now I currently have three elements. The only remaining element is 2 and 5. Since I need at least three prime numbers to make a strongly composite number, I cannot make a strongly composite number from these two numbers. So I can just take them and add to any of those elements. I can take this 2 and add here. I can take this 5 and add it here, and I can take this 5 and add it here, right? So no matter where I put them, it doesn't matter. The overall product will be the same, and the number will still be a strongly composite number, right? Otherwise, if there was some other prime factor as well, 7, so I would have taken 2, 5 and 7 together and I would have made them a strongly composite number, right? So this is exactly what we have to do in the code. I would, if the prime numbers are same, I can make them a pair. If the prime numbers are different, I can take three of them and make a new strongly composite number, right? Since if there is only one prime number left, I cannot make it a strongly composite number. If there are only two prime numbers left that are different, I cannot make them a strongly composite number. So I need at least three unique prime numbers. So if there are a count number of prime numbers left, my answer the value that it would contribute to my answer is count by 3. Since I would need a group of at least 3, right? So let me just show you the code for this particular problem now. This particular problem, I personally found it very interesting because it required some cool mathematics. So I have a vector of size v and of size n, and I've taken input in it. Now I initialize two variables, count and answer. So there's a map that I've created which will denote the frequency of the prime divisors of the number of all the values of v, right? So what I could have done is I could have taken all the numbers and calculated their product, and then for that particular product I would have done this prime factorization. Otherwise, what I could also do is I can just do the prime factorization for each one of them. So I've taken a value v of v of I, and I've done the prime factorization of v of I, right? So I just increment the frequency of the prime divisors of the value. Now if the final value of vel, that is the initial element, is still greater than 1, that means I can increment this particular frequency. So this is just normal prime factorization stuff, and I'm calculating the frequency of prime factorization in each of the array elements. Now at the end, once I have the frequency of all the prime factors, what I can do is I can just traverse through this frequency map, and if the frequency is in a pairs, right, I can count the number of pairs for each of the prime factors, and I can increment my answer by that number of pairs. Now if there is one element left at the end, after forming all the pairs, if there is one element left at the end, I can add that particular value to my count variable, right? So it will be I dot second dot count. So the pair will only have one element left, all the frequency will have only one element left only when the frequency is odd. So in that particular case, I can add 1 to my answer. At the end, I'll just add count by 3 to my answer. Since I need 3 prime numbers to make a super composite number, I'll just add count by 3 so that I can take them in a group of 3. At the end, I can just print my answer. So this would be the final solution of the last problem of this particular discussion. I hope that you guys were able to understand the solution. If you guys did, then consider dropping a like on this video, and don't forget to subscribe to this channel. It's always free, of course, and you can always unsubscribe if you don't find the videos interesting. So till the next video drops, keep coding, stay safe, bye bye.